Welcome to all. I am Assistant Professor Ahir Ma'am from SND College of Engineering and Research Center, Yola, Department of Applied Science. Today's online lecture on course Engineering Physics, Unit number 6, Non-Destructive Testing and Nanotechnology. In previous videos, we have already seen non-destructive testing. Today we will discuss about second topic in unit 6, nanotechnology, which content we will see in this video lecture. Let's see. Introduction to nanotechnology, types of various nanoparticles, nanotechnology evolution time. So, introduction to nanotechnology. So, first we will discuss about nano. The prefix nano is derived from the Greek words is meaning Greek words vavos and dwarf. Meaning of vavos is dwarf and dwarf, that is very small. Nano means very small. Has nanotechnology has come to mean a range of a highly promising discipline in science and technology. It can be used as a prefix for any unit like second or liter to mean a billionth of that unit. Nano symbol is small n, is a unit prefix meaning 1 billionth. Denotes 10 raised to minus 9 meter is equal to 1 nanometer. Nanotechnology is a science, engineering and technology conducted at the nanoscale to study for the applications which can be used across all the other science fields such as chemistry, biology, physics, material science and engineering. There are Richard Feynman's. It was then that Nobel laureate Richard Feynman urged mankind to think tiny at the scale of the atom itself. It was much later in 1974 that Noria used the term nanotechnology while measuring precise machining tolerance. There is a plenty of a room at the bottom, an invention to enter new field of physics. Nanoscience and nanotechnology involve the ability to see and control individual atoms and molecules. This is a examples of a nanoparticles. Medieval stained glass window. Nanotechnology is the science of designing, producing and using structure and devices having one or more dimensions of about 100 millionth of a millimeter or less. Such atomic scales fabrications is known as bottom-up approach as opposed to the top-down approach that we are accustomed to. Many of the applications of nanotechnology involves new materials that have different properties and new effects compared to the same materials made at large sizes. This is due to the very high surface to volume ratio of nanoparticles compared to the large particles and to effect that appears at that small scale but are not observed at larger scale. Nanotechnology is the understanding and control of a matter at the nanoscale, and this is a unique phenomenon unable novel application. Matter can exist physical, chemical, and biological properties at the nanoscale. And this differing is important ways from the properties of a bulk material and single atom. This is the scale of things: DNA, bacterium, large raindrop, single evolved carbon nanotube, strand of hair and house. The scale of a skin to DNA molecule. In first 10 centimeter, this is hand, next 1 centimeter, 3 1 millimeter, fourth 100 microns. This is a skin, and suppose that the grains 10 microns, 6 1 micron, 100 nanometers, 10 nanometers and 1 nanometers. The first stem image of a material, AFM images of a material and quantum dots. There are nanoparticles. In nanotechnology, a particle is defined as a small object that behaves as a whole unit in terms of its transport and properties. It is further classified according to the size. In terms of diameter, fine particles cover a range between 100 and 2500 nanometers, while ultrafine particles, on the other hand, are sized between 1 to 100 nanometers. This is quantum dots. So, what is quantum dots? Quantum dots are the class of materials in which quantum confinement effect can be evidenced. They are very small semiconductor crystals of the order nanometer size, containing merely 100 to 1000 atoms. Quantum dots are the subgroup in the family of a nanomaterial, which consist of metals, semiconductors, insulator and the organic material. The term quantum dots refers only in semiconductor nanocrystals, whereas any other inorganic material in the nano regime. The electronic properties of quantum dots lies in between bulk semiconductors and isolated molecules. Optoelectronic properties of a quantum dots mainly depends on size and shape. This parameter changes, property also changes. So manufacturing at the nanoscales is known as nanomanufacturing. Top-down approach involves the breaking down of the bulk material into nano-sized structures or particles. The biggest problem with the top-down approach is the imperfection of a surface structure and huge amount of a waste of a material. Bottom-up approach refers to the build-up of a material from the bottom, atom by atom, molecule by molecule or cluster by cluster. Bottom-up approach has the potential of creating less waste and capacity of a manufacturing very accurate nanostructure. So let's see examples of top-down approach and bottom-up approach. The example of a top-down approach is Ellora Caves in Aurangabad, and bottom-up approach Kalaram Temple from Nasik. Synthesis of carbon-based nanomaterials. So let's see. Nano manufacturing process. There are many different processes: chemical vapor deposition, physical vapor deposition, sol gel method, chemical method, electrophoretic deposition, roll to roll processing and self assembly. Let's say various nanoparticles. Nanoparticles is usually defined as a particle of a matter that is between 1 and 100 nanometers in diameters. Nanoparticle occurs variety of shapes such as nanotubes, nanowires, nanosheets, nanospheres, nanorods, nanochains, nanostars, nanoflowers, nanoreefs, nanoviscous, nanofibers, nanoprisms, nanobars, nanocubes, nanopyramids, nanorice and quantum dots. There are different types of nanoparticles: carbon based nanoparticles, ceramic nanoparticles, metal nanoparticles, semiconductor nanoparticles, polymeric nanoparticles, liquid based nanoparticles. So I hope you have understood this, what is nanotechnology, what is nanoparticles. Thank you.